Good afternoon, class. Today we're going to be learning write and graph exponential decay functions 6.3 and 6.4 part 4.
Perfect. Thank you, y'all.
Wow.
All right, so on your sheet, I think we already mentioned the formula, but you want to fill in the blank in the function y equals ab to the x. Now, Josiah asked me a question, and I said, nope, we're never going to use those kind of numbers. I said a and b would never be what?
Negative.
Never be negative. That's why right here it says a is bigger than 0. Right? A will never be negative. And now, in order to have decay, what did we say b had to be between in the warm-up? Had to be underneath 1, but it'll never be negative. It'll never be negative. So that's why we wrote here b is always bigger than 0. B is greater than 0, but it has to be less than 1 if you have decay. What if b is bigger than 1? It's not decay anymore. What does it turn into if it's bigger than 1? Yeah?
Exponential growth.
Exponential growth. Okay, we kind of did growth last week. We did a little bit of decay last week too, but we kind of focused mostly on growth. So today I think it's all decay stuff. All right, can somebody remind me, what does an exponential decay graph look like? I mean, does it look something like that?
No, it slams down to the ground.
All right, well, this goes down to the right.
No, it swoops, like,
It swoops.
it's kind of like,
Yeah, it has,
it gradually, you know how like waves go like this? It's
Yeah.
kind of like a wave.
yeah, so it curves kind of down like that. Okay, so the graph of an exponential decay function goes down to the right. It falls as you head to the right.
Oh, is that what we're supposed to write?
Where are we writing?
Wait, where are we writing that?
Never
You don't have to write that, guys. Don't worry about that.
Okay, so now we're going to practice writing some growth. We'll do some growth and some decay functions, okay, but we're going to do it by looking at a graph. So someone remind me again, how do you find A? It's the y value when x is 0. So you look for the 0, look at the number that's next to it, whether it's in a table, whether it's in a graph. Look for the 0, look at the number next to it, that's A. And then B, usually it's what you multiply by each time if you have a table. So let's look at it right here. So it says, tell me whether this is exponential growth or decay. Yeah, that's growth, right? How do we know it's growth?
It's not going to the right.
Well, it's going to the right.
Up to the right.
No, I mean, it's not going down to the right. It goes
Yeah.
up to the left.
It's going up to the right, right? Up to the right. So we call that growth, right? So we'll start with that. It says, write whether it's growth or decay. This is growth. Okay, so that's the first part. Now it says write a rule
So
for the
I think
function.
there's some steps that they have to write in.
We got some steps.
Yeah.
So determine if it's growth or decay. We already did that. Okay, so up and to the right, growth. Down and to the right,
And
decay.
guys, that stuff that's in parentheses, like up to the right, down to the right, if you know how to recognize whether it's both of decay, you don't have to write that. But if you want to remind yourself, then you can write it down.
I'm sleepy.
Now, anytime we want to write an exponential formula, right, whether it's growth or decay, we have to know how to set it up. So, like if we were doing something about a line, we would start with y equals mx plus b. I've already asked you this a couple times, but what do we start with for exponential? It's not y equals mx plus b. What
Heard
is
it
it?
a couple times today.
Yep.
That y equals a
B, X.
y equals a b to the x. And now we have to find the a and the b. Now, a we're going to be able to find very similar to how you've done it before. You're going to look for the 0 and it's the number with it. B we're going to have to do a little differently, okay, because we don't have a table this time. Look at what we have. We have a picture. Okay, so it's a little different, but not too bad. Does everybody have the up and to the right, down and to the right?
Yes.
All right.
Oh, yeah.
Okay, exponential formula, we should have that. All right. So now, how do we find A and the B? Well, let's start with how we find A, because that's kind of like what you've done before. It says you're going to look at the y-intercept. How do we know something is a y-intercept? It's where it crosses the axis. Well, anytime you cross an axis, one of the numbers is 0. So you're going to look at the one that's not 0. Just like you do with a table. You're going to look at the number with 0. Okay, so I'm going to go back up for a second just so you can see it. And then we'll come back down to
Yeah,
that.
so basically, guys, when we do this type of question, you're gonna have two coordinates, all right? You're looking for the coordinate that has, with 0.
So look at the coordinate with 0.
You wanna use that.
What's the number that's with the 0?
10.
It's 10. So this time A is 10. Just like a table. Look at the number with 0, and it's the one right next to it. Okay, so A will be 10. All right. So plug in the y-intercept, the number that's not 0. In our case, it was 10. Now, how do you get B? Well, we don't have a table, so we can't see what we multiplied by each time. So we got to do it a little different. We're going to use the other coordinate, not the one that was 0, 10. Okay, I'll just show you what the other one was. It was 1, 12. That's the one we have to use. So use the other coordinate. What did I say it was? 1, 12? I think it was in this case.
Yeah.
And we're going to solve for B. Okay, so let's look at our formula. Okay, well, we've got 4 spots in it, and we're going to fill in what we can. So I'll give you guys a second to copy it. Okay, so let's look at it. We have A, B, Y, X. We just said what A was a second ago. It was the number that was with 0. Fred, what was the number that was with 0?
Look at the graph, look at the two coordinates. Which number was
10. All right, so we got A. That's good. B. Well, B, that's the whole point. We don't know what B is, so we're just going to put a question mark. Y and X. Where do we get Y and X from? Right here. The other coordinate. Look at the other coordinate. 1, 12. Right? 1, 12. 1 is the X. 12 is the Y. So now, out of the 4 letters in that equation, what's the only one that I'm missing? B. If I'm only missing 1 letter, I can solve for it. So let's fill everything in and see what we got. So Connor, what am I going to plug in for Y? 12. Y is 12. So 12 equals, next thing I need is A. Ginny, what am I going to plug in for A?
10.
10. So A is 10 times B, I don't know. Now X. Gemini, what am I going to fill in for X?
1.
1. Nice. So now here I have B to the first power. What's B to the first power?
B.
B. Anytime you raise something to the first power, it doesn't change it. So all we have is 12 equals 10. And I'll put it in parentheses so it doesn't look like 106. It's kind of whatever. So we have 12 equals 10 times B. How do we move that 10 over to the other side and get b by itself?
Mine's inverse operation.
We use the inverse operation, so we have 10 times b.
10 divided by?
So we're going to divide each side by 10,
Yep.
and we get 12 tenths equals b. Now, 12 tenths. Somehow I deleted the page, but I think I got it back. All right. So we got 12 tenths, but what can we do with 12 tenths?
Reduce it
We can reduce it.
to 6 over 5.
Yeah. You can divide the top and bottom by 2, and there's your b. Now we've got the two things that we really need. We've got a, we had that right away.
Can we make it into a mixed fraction?
We'll leave it as an improper fraction. Yeah, yeah. It's a good question, but yeah, we always leave it as an improper fraction. If this came out to like 1 over 2, we would be okay if you put 0.5. If you wanted to, you don't have to, but you could put 0.5. Okay, now the last step is write your final answer. In the final answer, you just fill in the A and the B. You don't do anything with the X and the Y. So here's our formula. Y equals AB to the X. Don't touch the X and the Y. Just fill in the A and the B.
So our answer would be like 12 equals
Well,
10b to the first.
remember, the two things that I circled, they don't change. You're gonna leave them the way they are. Every final answer has to have X and Y in it. The only two numbers you're gonna have in the final answer, you're gonna put a number in for A and a number in for B. So don't change those two things that I
Yeah,
just
so
wrote.
doing kind of like the same thing we did last week, but last week we had like that table, like the chart, now we have a graph. Just doing it a different way, but the same formula.
So what's A? We said that earlier.
A is 10.
A is 10. And what's B?
Well, it's 6 over 5.
6 over 5. And that's it. That's the final answer. You don't do anything else with that. Now, in order to be growth, B has to be bigger than what number?
1.
Has to be bigger than 1. Let's check what 6 divided by 5
It
is.
is. It's 1 and 1/5.
Yeah, 6 divided by 5, exactly. 1.2. So it's just barely growth. It's a little bigger than 1, not a lot bigger. A little bigger. And that's it. That's how you do this kind of problem. So the only thing that's different is the last part of step 3. You find A the same way, but to find B, you got to make this little equation and solve it. Okay? Most of the time, I think X is going to be 1, because if it's not, it gets kind of hard. You get into square roots and stuff. So we'll probably keep X as 1. Okay? So I think we got another one just like that for you guys to try.
On our own?
It's up to you, Mr. Roy. You want to start them off a little
Sure, I
bit?
can do that if you want. Just get in my-
Maybe Mr. Roy will start you off, and then
Let's get a day of my life. Something today. Let me go room. Scared. Alright, Ginny, what formula do we want to use for this?
Y equals A.
It's okay, mistake. Y equals, good. Y equals A times B to the X, very good. So there it is. Alright. Now, what am I going to fill in for, Sophia, what am I going to fill in for Y?
I forget.
Okay. So I'm going to help out Sophia, we're going to fill in for Y. No. Once I take, this is like this my little hint to tell me that, okay, 8 has a 0 with it, right? So I want to make sure I'm going to use this for something else, all right?
4.
Right. I'm going to use this other coordinate, right? Remember, we're going to go in alphabetical order. Here's my x, here's my y. So y would be 4. All right. How about A? What's that?
It's the one next to the O, I mean the 0.
Yeah, one next to the 0, which is going to be
8.
8. All right, to get A, remember it's the one that has, it's the coordinate that has a 0. It's the number with 0. So I'm going to put 8. How about B? How about page? How about B?
You don't know yet?
Don't know yet. It's kind of a trick question. We don't know yet, right? So we're just going to leave it as B. And Will, how about X?
X, would you just leave it?
Nope. I already had the letter I'm going to leave.
Oh,
1, right? Remember, how did you know that, Will?
because that's X.
Yeah, right. Again, once I get my A, right? I know the number with 0 is my A. Once I get that, I don't need that other coordinate. I don't need that coordinate anymore. The coordinate with 0. The coordinate 0 is telling me the number with it is going to be my A. Once I get that, I don't care about it anymore. I can cross it out. It doesn't matter. All right. So now I'm going to have 8 times B, which is
8B.
8B, right? Good. My last step here would be what? What's my last step here,
Divide
Fred?
by its inverse.
Hard.
What's my last step here?
To bring it over.
1. By doing what? What math operation? Divide. By what number? Sure you do. 4. 8, right? Always want to, since the first day of class, always want to divide by the number that has a variable attached. B equals
1/2.
1/2, right? Yeah, I'm just going to reduce this, right? I can divide by 4
Why can't we do a test on this?
in both.
That'll be
So B equals 1/2. So now I have to rewrite my function. What are the only two what are the only 2 letters when I rewrite it? What are the only 2 letters I want to plug in for now?
A and B.
A and B, very good. All right, so Y equals, what's my A going to be, Noah? I'll give you a hint. It doesn't change from when we wrote in this function. 8, right? That doesn't change. How about my B?
Unknown.
Just solve for it.
Oh, 1/2.
1/2. Paige, what's the last thing I have to put?
X.
This little x, right? This little exponent. That's it. Now, we didn't do it at the beginning, which we should have. I forgot that part. Because it's going to ask us whether it's growth or decay. Now, if I only had that function, if I didn't see this graph and only had that function, what would it be? Growth or decay?
Growth.
Decay. Why is it decay? Gemini.
Oh, because B is less than.
Yeah. The B is less, remember, for it to be decay, it's going to be a range. It's going to fit in a range of numbers, right? It's going to be between 2 numbers.
1 and the little numbers.
No.
0 and 1.
Good, no. 0 and 1. It's going to be between for it to be decay, it's going to be between those numbers. Like we talked about at the beginning. You're probably thinking in your mind like, oh, decay, it's going to be negative. No. Growth and decay will never be negative when we're doing this kind of stuff. We're doing exponentials. Right? So it's basically when it's a fraction. Right? When you have a fraction, that means it's going to be decay. Or if it's 0 point something, that's when it's going to be decay. Right? Anything greater than 1, I don't care if it's 1.73, 20.35, right? That'll be growth. Growth can still be a decimal, right? Growth can still be a fraction. But what type of fraction is it going to be? Like we saw in the last example. Growth can be a fraction. What type of fraction is it going to be? Besides? Huh? It could be a mixed number, or to get that mixed number, what would you have before that?
Like an improper.
Improper fraction, right? Like we had in the last one, we had 6 over 5. You're like, oh, well, that's decay. No, it's not. Because the number on the top is bigger. If it's an improper fraction, it'll be growth. If it's if it's a whole number, if the number before the decimal point is 1 or whatever else, it'll be growth. It'll be decay. Anything between 0 and 1, that's decay. All right? So yes, this will be like you guys just told me, decay. And plus, if we looked at it from the beginning, look how it goes. Down to the right. Remember, down to the right, decay. Up to the right, growth. It's that simple. So again, this is something new, obviously, that we didn't get to last week, because we just kind of ran out of time with the MCAS schedule and stuff like that. But this is just similar to what we did last week, but last week we had the chart. This week we have a graph. That's simple. All right, questions on this?
No, but
Simon,
yeah, but I want to say something.
go ahead.
Okay, the way I remember the graph is like it's in the shape of an L for loser, and loser's decay.
Okay,
They go down.
that works too. All right, so we're good with this? Are we good with this? All right, so we kind of talked about this a little bit in the beginning in the warm-up. So like we did with exponential growth, we'll use a similar function to solve word problems for exponential decay. All right, so we kind of talked about this a little bit in the warm-up. All right? Okay, so when a quantity decays, remember last week, right? We did exponential growth word problems, and it showed things that were increasing in value, or increasing the amount, whatever the case may be. All right, we did like stuff with investments, and over time, investment should gain some money. All right? So here, if it decreases by the same percent over equal time periods, all right, we're going to use a similar formula to what we used from last week.
Don't get confused when it says like decreases by the same percent over equal time intervals. So like, let's say you made $20 an hour, and I said I'm going to decrease your pay by half, by 50%. If you went, you'd go from $20 an hour down to what? 10. And then I said I'm going to decrease it again by the same percent. I'm going to decrease it 50% again. You'd lose half your money again. So you go from 10 down to 5. And then I said, you know what? I'm going to decrease your pay again by 50%. What I'm doing there is I'm decreasing your pay exponentially. Your pay is decaying exponentially. You're losing half of it each time. Every time. Half, 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 half. That's all that means.
All right. So, the formula is going to be very similar to what we did last week. What do you think the one thing is that's going to change? So we already talked about y equals a times b to the x. That's when we want to set up an actual function. Now, if you have a word problem, this is a formula we have to use for a word problem. All right, so we'll start with, like Joe just said. So y equals,
And then it's
I like that.
R, A,
Then we have the a.
and then 1. With
Before-
a parenthesis.
Good.
And then the 1.
Then we have the parentheses. Then we have the 1. Now
R.
here's where the difference is going to be. We're talking decay, right?
Oh,
So we're going to minus. So kind of like we talked about in the warm up, right? We're decaying now. So we're not going to increase. We're going to decrease. That's why this is a minus. Everything else is, as far as the rest of it goes, all exactly the same. All right? Everything else is exactly the same. So that's this. The minus is the only thing that changed. That's it. Because it's decay. So it's not going to increase in value. Think about the name. Decay. It's going to go down. It's going to decrease. All right?
the 2 fine, Mr. Roy? I'm not sure if that,
Yeah, the one that's there.
maybe it was something else.
That's it. Again, the initial amount, right? How much you start. Are we talking about a population? I think on the test we talk about different populations of animals. All right. It could be money, like what you invested originally, whatever you're starting with. All right. Your 1 is this part of the formula. It's there. Minus. Remember the rate. How are we going to find the rate in the problem? It says as a decimal. How is it going to be written in the actual word problem? How are we going to be able to find it? How are we going to know what the rate is? Percent. Good, Savannah. Right? And Mr. Hager was showing you guys again how to make it a percent to decimal. Remember, the decimal point's going to be, if it was 7%, even though it's not there, the decimal point's always to the right. So it can be like 7.0. If I want to write 7 as a decimal, it would be 7.0. To take this as a percent and make it a decimal, I want to go 1, 2 to the left. Wherever there's a blank spot, I'm just going to fill in with a 0. Alright? If we gave you like 3.5, same thing. 1, 2. So it would be 0.035. Alright? So, same thing as last week. Only thing that's different is instead of plus, it's minus. Everything else the same. Alright. So example 3. This is number of, I think you guys have this written down, right? Alright, so the number of acres of pine forest decreased in the western U.S. from 1963 to 2002 by 0.05% annually. In 1963, there were 41 million acres of pine forests. So the first two things you're going to write, down here have nothing to do with this problem. What are you going to start with?
The equation.
Okay, so what are the first two things in that equation?
Y equals.
Yeah. So just like if we were writing like a slope formula out, right? It starts with y equals. All right.
Wait, would it be 41 million?
Huh?
41.
Yeah, we're just gonna put 41. We're not gonna put 41 million. We're gonna put like 41, 0.000, 0.000.
It's like, I don't wanna.
What do you want to do?
X, what do you want to put, buddy?
Never mind, I can figure out what.
So y equals, in our formula, right, Ginny? In our formula, we had y equals, what was the thing that comes after equals? 41. Why are we putting 41? I agree with you. But why? Why wouldn't we put like 1963? 1963? Why wouldn't I put that in the A spot? What's 1963? A year, right? I don't care about that, right? What were you gonna say, Noah? So why are we gonna put 41 as our A? Mallory?
Initial amount.
That's the initial amount we're starting with in 1963. I'm just gonna put a 41. Z, after the 41, what are we gonna put? Parenthesis, and then what? A 1. Well, give me one more thing after the 1. Minus. Thank you, buddy. So, Z gave us the next three things, the parenthesis, the 1, and the minus. All right, Jack, what comes next? You can look at your formula. So we've done the y, we've done the equal sign, the a, start our parenthesis, put our 1, put our minus. What's the thing after the minus? Oh, you know, so he's copying down this formula, right? Did you copy it down?
You're shutting all my signals.
Okay, so after the minus sign is what?
Wait a moment, inside of parentheses, letter for minus. You have it written.
What letter do you have there?
What's wrong?
R, right? And what does R stand for? And in this problem, what's the rate?
Yeah.
Alright, so 0.5 was 0.5, right? But to put it into our actual formula, what am I gonna make sure I do? Huh? I gotta do something with that decimal point, right? Where do I move it? To the right or to the left? I'll move to the left. How many times? 1, 2 times, right? I got a blank here. What should I put? 0. So what do I get? Point what? Yeah, 0.005. 0.005 and my parenthesis. Now, Sydney, what's the last thing I have to put? So I figured out my A, I figured out my B, I got my parentheses, I got my minus sign. What's the last thing I gotta figure out? The time, right? Now this one's different from other problems that we've done, right? How is this one a little bit different from other problems we did like last week?
It doesn't give us the time.
Doesn't give us the time.
So you have to figure it out.
How would I do it, Sydney?
What's the dates of the review?
So okay, the dates are given. So I got 1963 and I got 2002. How would I figure out the amount of time that's gone by? Hold on. Exactly, right? So Mr. Hager's gonna do it. What was it, Joe and Amy said? 79?
It was 39.
3:30. Oh yeah.
39 years. Wow.
Let's check it out.
I'm stupid.
39. So remember, that's stupid. You made a mistake. Oh my God. All right. So remember, we're putting 39 as an exponent. All right. Now, this next part, I could do all this on my calculator. Everything. All right. So if I just, so I'm gonna do 41. I'm gonna go parentheses. I'm gonna go 1 minus 0.005 end parentheses. How do I do the exponent again? Calculate. Good job, guys. So say, do you want to round that up a little bit? I mean, round it or
Yeah, 1 decimal.
1 decimal. So guys, how many acres would be left? How many acres would be left?
33.
33.7. So almost 34.
Is that it?
But they lost a lot of acres. They had 41 million and now they only have 33.
It's still
It's
because
still millions,
it's
right?
a loser. They're decaying.
So that's not 33 acres, that's
Wait, is that it?
33.7 million.
That'd be awesome for Florida.
That's how much they lost.
I thought that's how much they had now.
That's how much they have now, yeah.
How much like that? How many acres would you have?
So yeah, they've lost over that amount of time in 39 years. They've lost 7.3 million acres.
That's a good life.
Right, so,
That's a rough life.
That's a lot of.
so guys, this type of question right here would be something you might see on the final exam.
Oh my God.
We may again, like we did last academic week, we may ask you just to set it up, right? You don't know the amount of years that have gone by, so you just leave it as T, but you'll have everything else filled in. You might see that type of problem as well. All right? So you're doing a graph. So guys, that's just a look. That's just what it would look like if you graphed it.
This is what they
See how it's decay, but it's very slow.
Yeah.
Very
So
slow.
guys, again, it's only 0.5%. You're only losing 0.5%, but you see how over time you're gonna get some loss.
So here's what the graph looks like over 500 years. You can start to see the curve more, but it's still slow. But look, after 500 years, there's almost nothing left.
Because again, But exponential is just like whether it's growth or with decay, it's not gonna, at first, it won't be a lot. But then over time, you really start to lose. Same thing with growth. You won't gain a lot at first, but over time, you'll really start to gain. Alright? As far as this week, what we're going to give you today, alright, is part one of the exam review. Some of the guys, please listen. Some of the stuff is relatively, you know, you kind of, you didn't do it that long ago. Alright, it's the like exponential stuff we did this week, exponential stuff we did today, but there's also stuff on exponents on there. Negative exponents, that kind of stuff. Alright? Again, Mr. Hager mentioned at the beginning of the lesson, today was the last day of new stuff. From here on out, it's review. Alright, for the next 4 days of class, or next 3.5 days of class, because we only have one period on Thursday because of MCAS.
So is this our only page of notes?
That's it? Guys, tomorrow we'll start preparing for the final exam. We're going to give you the reference sheet, alright, with all the different examples written on there. You have to go back into your notes, go back on the math with Hager, and get them all filled out. Again, you want to make sure you write the directions. If it's a word problem, write out the word problem. Don't just write the answers. Alright, I think some of you guys realize that on tests we've had second half of the year and on the midterm as well. Alright?
Passing out our test scores.
Okay,
So guys, make sure, like Mr. Hager just added, added on the thing. Make sure you bring your notes tomorrow, so you can look back at those, or bring your Chromebook so you can look on Math with Hager to find the example. Alright? Reference sheet, guys. So, Mr. Hager might have mentioned before I get up here, we'll give you all of class tomorrow and half of class on Wednesday. So that should be plenty of time for you to get it done. So basically what we're saying is, unless, I know some people tomorrow have to finish a test, they have to finish making it up.
Wait, can we use that on the exam?
Huh?
We get to use that on the exam, right?
No.
What?
I'm just making you guys use all this time in class.
I'm so confused.
Of course you can, yes, you can use it in front of
Why are we
us.
gonna make a reference sheet that we can't use?
Alright, and again, alright? And then guys, final, 2 weeks from today, so your next academic Monday, understand, listen, you have a whole week of shop. How many days, Mr. Hager, is it? You figured it out.
18 days.
Yeah, you got from Friday to Monday, from the next academic Monday, from this academic Friday, is 10 days.
Ash.
I'll still be after school. I'll be after school Monday and Thursday of next week if people want to stay to review with me. That's fine. Alright? Guys, keep your notes out. I got a couple practice problems I want you to work on.